Hello, hello. Okay, so in this video, we're going to just take a look at two examples of finding Taylor series. So we want to find the Taylor series generated by the given function at x equals a. Okay, so these two examples, I just want to point something out before I start this. So notice that with this first function, so as I continue to take derivatives of this, eventually the derivatives are going to go to 0. So this is going to have a different result than if I do the next one, which if I take derivatives of this, I can just take derivatives of this for forever. This will never end up going to 0. So this is going to give us two kind of different things, two different types of Taylor series, in that this one will end. Okay, so let's just jump into it. All right, so to generate your Taylor series, the first thing that you need to do is you need to take a bunch of derivatives. So since I know that these derivatives will eventually go to 0, I am just going to keep taking derivatives until I get there. Oops, and this should be 12x squared, my bad. Okay, and then let's see, the third derivative, I can't write. The third derivative is 24x. The fourth derivative, I really cannot write. The fourth derivative is 24, and then after that, all the other derivatives go to 0. Okay, so now what I need to do is I need to evaluate all of these at a. So I'll go ahead and do that. I think I can fit that information in here. So if I do f of a, f, what can I say? Maybe I need another cup of coffee here. Okay, f of negative 2 is 25. F prime of negative 2, so plugging negative 2 into this. I worked this out ahead of time, so I'm just going to tell you what these values are. F double prime of negative 2 will be 52. F triple prime of negative 2 will be negative 48, and then the fourth derivative of negative 2 will be 24. Okay, so now that I have this information, this is really what I need to move forward with this. So let me clear some space. Okay, so from here on out, now we're really just filling in a formula. So let me just show you the formula that we're filling in. So this is really what you're going to do. But for this particular series, since my derivatives kind of die out after 4, I'm actually just going to write out all the terms of this. So I am literally just filling in this formula at this point. So f of negative 2 was 25. And then f prime of negative 2 was negative 40. And then I'll take x. So x minus negative 2 will be x plus 2. So I'll write that. The next value is going to be, let's see, f double prime, which will be 52 over 2 factorial times x plus 2 squared. And then I'm going to have negative 48 over 3 factorial, x plus 2 cubed. And then my final term will be 24 over 4 factorial, x plus 2 to the 4th. And after that, everything is just 0. Okay, so if your derivatives just die out like happened here, then you will just write out the entire series. And okay, so now I just have to simplify this. So this becomes 25 minus 40 x plus 2. 52 divided by 2 is 26. 48 divided by 6 will give me 8. And then 24 divided by 4 factorial is 24 over 4. So this just leaves me with x plus 2 to the 4th. And so that's it. Okay, now in my Maclaurin series video, I did a very similar series, and I got back to the same polynomial. So the last thing that I want to state about this is that if I went through all of the algebra to multiply all of this stuff out and collect all my like terms, what would actually happen is that this would get me back to the original polynomial. So all of this just equals this, which makes sense because the polynomial is going to be the best thing to, you know, effectively like model itself, right? This isn't an infinite, this isn't like an infinite series that goes on for forever. It doesn't have a billion derivatives. So this makes sense in this context. So now let's contrast a slightly different example. So 1 over x squared. So, okay, in this case, we know that the derivatives are actually going to just cycle. So let's take a few derivatives. So I want to just remind you 1 over x squared is x to the negative second. So the first derivative will be negative 2x to the negative third. Now, a best practice when you start taking derivatives, I think it's best to not multiply the numbers together. You're trying to establish a pattern. So if you're starting to multiply things together, just write them out like this so that you can see the pattern. So if I take the third derivative, now I'm going to have, let's see, this will be negative again. So I'll put the negative, negative 2 times 3 times 4, x to the negative fifth. So at this point, I feel like I can establish a pattern. So you always take as many derivatives as you feel that you need to figure out what the pattern is. So my nth derivative, let's see. So this is really 4 factorial. So that is 1 more than the third derivative. And then this negative alternates. So this is clearly going to be negative at all the odds. So at the first derivative, so when n equals 1, this will be negative. So I can just write this as negative 1 to the n. So first derivative is negative, third derivative will be negative, so we're all good there. And then we have n plus 1 factorial. So this is the third derivative, and I have 4 times 3 times 2, so that's 1 more than the third derivative. And then this, so this really starts at negative 2, and then this is subtracting 1 for each derivative. So this is negative 2 minus 1, negative 2 minus 2, negative 2 minus 3. So I know that because that's where my original function was. So this is going to be negative 2 minus n. Okay, so there are all my derivatives. And so now I can plug in my value of a equals 1. So f of 1 equals 1. F prime of 1 equals negative 2. F double prime of 1 equals positive 3 times 2. So we'll just write that as 3 factorial so I can see the pattern. F, let's see, I feel like I can probably just establish what the pattern is here. So the nth derivative of 1 is going to equal negative 1 to the n times this n plus 1 factorial. So if I'm plugging in 1 for x, that just goes away, so I'm just left with all of this. Okay, so that's everything that I need to actually build out my series. So let me clear some space. Okay, so just a reminder, the format that we're trying to follow is this right here. So I'm just plugging everything in at this time. Okay, so my f of 1 is 1. My f prime of 1 is negative 2, so this will be negative 2 times x minus 1. My next term will be 3 factorial over 2 factorial, and then x minus 1 squared. I'll go ahead and build this out to maybe one more just to establish the pattern. So the next one would be 4 factorial over 3 factorial x minus 1 cubed. So if we go out to the nth term, this will be, we said this was, oops, I'm sorry, this should have been negative, my bad. It's alternating. Okay, so this will be negative 1 to the n plus 1 factorial over n factorial x minus a to the n. Okay, so now I can see how to simplify all of this. I can feel pretty confident in how this simplifies, so I'll clear some space. Okay, So this will simplify to 1 minus 2 times x minus 1 plus 3 times x minus 1 minus 4 times x minus 1 cubed, so on and so forth. So the, I wrote x minus a, this should have been x minus 1, my bad. Okay, so all of this then can be rewritten as a series, so from n equals 0 to infinity. So this will just end up being negative 1 to the n plus 1, x minus 1 to the nth. And so that is your Taylor series. Okay, so hopefully that kind of helps. If you want to see some more examples of like building series, I do have a video on Maclaurin series where I do several of these, so check that out as well. And I will talk to you guys in the next one. Thanks for watching.